chain rule is used when we want to find out the derivative of a function within a function. So, for example, this function here, it's a quadratic function. So, to the power of, rather than expanding, one way is to expand the whole function. But rather than expanding, we can use chain rule. Alright, so this is what the formula says. du over dx times dy over du. That's how we use the chain rule. So everything that's inside the parenthesis or inside the bracket is u so we differentiate, and with respect to u with respect to x, u du over dx. So that gives us 2x plus 3. And we also, because everything that's inside the bracket is u to the power of 3, so we differentiate y with respect to u. dy over du is 3u squared. So my dy over dx equals to, so the diagonal is u, so du there and du there, and you want your denominator to have dx and the numerator to have dy. So we know that du over dx equals to 2x plus 3, and dy over du equals to 3u squared. So we rearrange. So that gives us 3 out, 2x plus 3, and u is x squared plus 3x plus 7 to the power of 2. So that is my dy over dx. That was a function within a function. Let's look at a scenario where we have a sine function or a cosine function. So let's say my y equals to, let's say my second example. So everything inside the parenthesis is u, and we differentiate with respect to u, du over dx. So we differentiate u with respect to x, so that's 4, and we also do the same thing dy. So the derivative of dy over du is cos u, and my dy over dx, I just substitute, that's going to be 4 cos 4x, and that's it. So look, another one where we have to get a square. So let's get another example. Let's say I have something similar to that. The first thing I do is I rewrite this whole thing. So that means y equals to sine. I'm going to put a bracket, the whole thing. And that's what it is. So I am going to say everything that's inside. So that means I have to differentiate this twice. So that means that's everything inside. So if I say y equals to u squared, and I say u is this sine 4x squared, and I still have to use, so that means I have to use chain rule twice. So I use chain rule again, I'm going to say again, everything that's inside there is u again. That's going to be another y. So if I differentiate that, so that gives us du, this du over dx will give us 8x, and that will give us cosine. So that means I also have to differentiate this again. So that means I got that bit. So that was du over dx up there, 8x dy over du cos u, and I still have to differentiate that there. So that means if I differentiate everything that's inside there, because that bit there, what's inside is basically that cos dy over du 2 cos, so this bit there, u sine u, and that gives us, so we already know that du, so that bit there, so we need to get dy over dx, so that's 8x times 8x to bracket 2 cos u sine u, and we know that the u is x squared, dy over dx is, so that to take it outside, that's going to be 16x cos 4x squared sine 4x squared. All right, let's check another example based on cosine this time. Let's say we have that. I want to use my du over dx is 28 x to the power of 6, dy over du is negative sine u, and my dy over dx should be negative 28x to the power of 6 sine u, and we just have to substitute dy over dx, negative 28x to the power of 6 sine 4x to the power of 7, and that's it.